Hey guys, so back with another video. So I've already done a video on how I went about mounting this flat mounting this Gen 2 Starlink on top of my car. But that setup, or this setup, was still being powered by 230 volt AC current, as in the router that's connected to this dish, which was also powering the dish, was being supplied with a 230 volt AC current, which was being supplied by a power station, a lithium-ion power station with a pure sine wave inverter, which was a bit of a cumbersome setup because as much as we do carry around this particular battery setup, we don't always have the room for it. So if we have all the 7 seats up, we didn't necessarily have enough space for this the lithium-ion battery to be installed in the car. So yeah, so the lithium-ion battery we carried around was a Bluetooth AC 180, which also I have a review of in the same channel. Yeah, so since then I have converted this setup to be running solely on 12 volt DC current. Well, there are so many ways you could go about doing this, and there are so many videos you could follow. But in my case, it was a bit different because normally when you convert the Starlink to run on DC 12 volts, sorry, yeah, so normally when you convert this Starlink to run on 12 volt DC, you typically have to work with 12 plus voltages, as in typical car battery has about 12.8, 12.6 volts if it's good, and when you have the alternator running, it could go up to 13.8 or even 14 volts. Yeah, so that's your typical 12 volt scenario. But in my case, it was a bit different because because I was using the 12 volt supply at the back of the car, and when you draw anything more than 60 or 70 volts, I don't know if it's a problem with this car or not. I was dipping below 12 volts. I was reading about 11.8, 11.9 on the socket when I was drawing more than 70-ish or so watts. So I had to negotiate with that as well. So my circuitry that I have installed in this setup was able to negotiate with a vast range of voltages. What I'm trying to say is, so it was able to accept anywhere from 9 volts to, let's say, 15 or 16 volts even in certain cases if the voltages was that high. So yeah, so hang around. Well, I'm pretty sure this is not the best way of best way of doing this, because I had to negotiate with all these different types of voltages. This was not the most efficient way of doing things, as in the normal AC, when the router was running on AC current, it was drawing about 45 to 50 watts on the AC supply from the power bank. But the same unit, when I had converted to DC, it was drawing about 65 to 70 watts. So I'm pretty sure I lost the efficiencies during the conversions of the voltages. So yeah, like I said, this is not the best way of doing this, but still I managed to get this one running, and I could run this one theoretically on 9 volts as well, as long as you have enough current. This is how I went about converting my Starlink to run on 12 volts. So if you have any ideas, any ways that I could improve this system, please leave it in the comments. I'll be reading all the comments on this video. Yeah, so this is the video. Cheers. Hey guys, so with a bit of negotiating, I have managed to remove the glue around the router. So it took a better part of an hour to go through all around with these tools. All 4 of them I think were involved at some point, and that's it. So that's a glass, that's the lid taken off, and there's your glue line. So it's pretty hard to get in with a knife because the surface that the glue adheres to is at an angle, not the angle that you're going in, it's at a flatter angle. I have taken out the front glass of the Starlink router, and after that you've got to remove these couple of plastic rivets, which I've already removed. You could use a 6mm drill to drill it out, and simply lift up the metal shroud there. So just be careful, there are a lot of plastic rivets spread throughout the router. So, and once you remove the metal shield, which is I think also a heatsink, this actual bit, which I've also removed, is the actual router part. Right at the bottom there is the cable coming in from the digi. Yeah. So I'm gonna use this circuit, but instead of using this circuit, this is the power supply circuit. This is what receives the 230 volt AC current and converts it to DC for this board to use. It's doing it through these 8 pins. So if you look closely, you will see the pinout diagram of that 8-pin array. What I'm gonna do is I'm gonna match up the voltage into these pins with a 48 volt and a 12 volt power supply, and I'm gonna tap the car battery into producing 12 volts that I need for this circuit. So that's the exercise that I'm trying to do now. Hopefully it should work, otherwise I'll have one fried Starlink router board in my hand. Right, fingers crossed. Alright, that came out easier than I expected. That's your AC circuit board with the connecting pin, 8-pin array. Yeah, so this I don't need anymore because I'll be solely using this router on a DC setup. So I'm just gonna put this one away. Yeah, hopefully I should need this one back. Well, let's see how this goes. Also, please be careful when you remove this, because there are multiple capacitors on this array. So if you had just removed the power to this circuit, you could get yourself electrocuted if you just touch the lucky pins. Yeah, so just be careful. Just a word of caution, when you remove it, just make sure you have unplugged it for a while, and the capacitors has lost its charge. Mainly this capacitor, but there are also a number of other capacitors that could also electrocute you, so just keep that in mind. I'm also gonna remove this black shield. I think this is what's blocking the back side of the AC circuit from touching into the shield, the metal shield, or it will get shorted out. I think that's the whole purpose of this plastic bit there. I can't think of another reason. I think that must be the only reason. Yeah, so I'll put the router bit back in. I've still got to work out what sort of a layout I'm gonna use to put all the DC components in the box. So I've got some of the components already with me, but I'm still waiting for just one component to arrive in the mail. So hopefully I will get it tonight or tomorrow. So when I have all of them in order, I'll walk you through my plan on how to convert this to run solely on 12 volt power. Yeah, so that's the sit trip for now. The circuit back in, and I've removed the AC circuitry there. I'm using this space to all the DC to DC conversion circuits. Right. So I think I've got all my ducks in a row at the moment. I'll go through what I'm going to do. So so that's your router, and these are the DC components. So if you look at the router, yeah, come on. Yeah, you've got these pins there, all right? That's your feed-in supply, a DC feed-in supply, and you got corresponding pins on the AC main board, right? Those are these pins. So you got to have DC 12 volt and 48 volt supply, and obviously ground. Also, you got two LED indicator lights. That's what's lighting up the bottom light at the router, right? So in order for us to convert this to run on DC, we need to supply 12 volt and 48 DC, right? So this is a step-up converter that runs off of your 12 volt supply from these two leads and converts it up to 48 volts. All right, that's what this does. So that's your 48 volt supply. But I've heard a couple of rumors online that these converters might be a little too noisy sometimes. Noisy as in the sense of electrical interferences, not necessarily audible noises. There are expensive ones, but for the time being I'm gonna use this one. This is about $30 on Amazon. So there are a couple of higher grade converters, mainly from the Meanwell brand, floating around, but they are around the $70 to $80 mark. So for the time being I'm gonna use this one, despite what I read online, and some people have successfully got their routers to work off of this converter. So I'm gonna take my chances with this one and this one. So the problem with running the 12 volt in your car, from your car directly onto the router board, is it could be anywhere from 12.8 to 14, depending on where whether the alternator is running or not, right? That's simply how it works. So you can't expect the car to supply direct 12.0 volts. So in any car that's the same, right? So you have to have your own 12 volt regulator to stabilize the 12 volt supply. But this car, as in this model, perhaps some other cars as well, where you tap into the car 12 volt system, this is the power supply at the back, the boot cigarette lighter port. When you draw enough amps through that port, your voltage could drop down. That's because they've used mostly because the lower gauge wire to run the power from the battery up to the rear boot. So if you use a lower gauge wire, you will see some voltage drop across the wire as well. So that's happening in this car. So let me show you what I mean by the voltage drop. So at the moment I'm connected to the sorry, excuse me for the state of the car first of all. I've just returned from a trip. So that's the power outlet in the boot, and that's supplying, that's charging the Blue Yeti power supply at the moment. It's only drawing 21 watts, but the car is on and the engine is off, so all the electronics are running. This is actually, this car has got what they call a smart alternator. So when the car senses the battery is topped up, the vehicle battery is topped up, it's shutting off the alternator, so it's no longer producing any current from the alternator. So the car, as it is right now, is running off of its main battery, right? So when that happens, which could very well be while the car is driving as well, okay, the voltage reading, which is not the most accurate measurement, but I have confirmed that with a multimeter, that's reading, that's actually fluctuating between 12 and 11.9. so that's only while drawing 21 watts. That's not even 2 amps, right? But given that there is also a loss on the wire, obviously, but so you get my idea. So when I'm pulling 30-ish, 35-ish watts for the Starlink, I will drop below 12 volts. So if you draw enough amps through that port, you're looking at around 11.5, 11.6 each volts. So which is even lower than what the router board requires. So that's where this data comes in. So this is a step up DC converter, as in this could receive anywhere from I think 3 to 36 volts, and it can output anywhere from I think 5 to 35 or 40 each volt. So it doesn't necessarily regulate. I mean, I'm pretty sure it does at some level, but most importantly for me, what it does is it's stepping up your voltage where your voltage requirement is not met. As in, if you input 11.5, 11.6 ish volts to this side, and this one you can dial with this dial there, you can tune it to output 12.0 volts, and that's the display for that. But don't trust the display. Again, you can trust you trust your own multimeter. Yeah, so that's the purpose of this one. So this one boosts. This is a DC step up DC to DC boost converter. So this will stabilize your voltage if you have a problem like me in the car where you can't really meet the 12 volts in this amperage requirement. So typically you're looking about 3 to 4 amps for the Starlink at 12 volts, more like 30 to 35, 40 watts. So that's about 3 and 3.5 amps. Well, you guys would already know if I was successful or not, because otherwise I wouldn't put this on YouTube if I wasn't successful. But if I come across any problems with this setup, either via this conversion method or using that converter, if I come across any problems later down the line, I'll update the description. I'll update the title to reflect any failures that I come across. So yeah, hopefully this will work. If you see in the video, this would have worked. Alright. Right, so situation update. This was gonna be the layout, the final layout. So I was hoping that I could just feed in the 12 volt here, goes into both the 12 to 48 converter and then 12 volt stabilizer, and let's just get rid of this one out, and goes into these respective pins on the router main board, right? Then again, I've also taken out the heat sinks around the inside of the router, because I don't think I will need them, as I've put some heat sinks on the most heat generating components on the board. These are some of those cheap heat sinks that I bought from J-Car, I think, or Electronics, I can't remember now. And yes, sir, I'm gonna put a fan in here somewhere, a small 30mm DC fan. So that's where this circuitry comes into play. So this one will receive 12 volt, and it will convert it to 5 volt for the fan to use. Yeah, so that's what I was going to use this for. But since then I've learned that this circuit that I was going on about cannot reduce the voltage. So this can only step up the voltage. So if I'm receiving 11 point something volts in the rear, this will surely be able to boost it up to the required 12 something 12.0 voltage. But if for some reason, as cars do, I receive 13.4 13.5 volts, this will pass it straight through to Starlink router. Right, so I can't use this one by itself, so I have to have a circuitry to address low voltage, and then I have another circuitry to bring it down to the required 12.0. So for the time being, I'm going to use this circuit for that that purpose. This one's got a, it's very hard to read because I've had this one for a while. 25 LM2596C chip in it, so this will reduce. This is actually a reducer. There's a potentiometer here, so this can receive up to I think 35 volts, and it can reduce it down to something 3, 4, 5 volts. Yeah, so I'm gonna use this one, which I was originally gonna use for the fan, in conjunction with this one. So this one will receive the, let's call it 11 or 13 or whatever the voltage is, and this will up it to somewhere around 16 or 17 volts, and that will go into this circuit, which will bring it down to 12. I'm sure there will be some losses because of this inefficient arrangement here, but I can't have it both ways, guys. So I do not know much about electronics to design my own circuits, so I'm just going to use whatever that's available on the shelf. I'm pretty sure there are much better options, but for this particular arrangement, I think this will work fine, except that I don't have much room inside. So I'm gonna have to do something about that, because I'm pretty sure I won't be able to put the cover back in, because this, even with the 12 volt to 48 volt adapter, I'm already jutting into the glass front fascia. So yeah, so about the fan, I think I'm gonna need another one of these for the fan. So there'll be one of these and two of these, one of them for the Starlink and another one for the fan. The fan one will have to output I think 5 volts, and this one has to output 12.0 volt for the Starlink. So I hope that's clear. So I'm gonna have to come up with an arrangement where that one and two of these will have room inside this router box. Alright, so here's the proof of concept. Excuse my noisy fan here. So yes, the 12 volts coming in, there's the multimeter, 12 volts coming in, going into this boost converter, ramping it up to 15, and this one is reducing it back down to 12.0. Also the same 12 volts going into this 48 boost converter, and both of these are feeding into the Starlink router PCB. So I've got signal, I've got Wi-Fi working, the proof of concept is working. Yeah, so it's a matter of putting it all back together in the box and packaging it. Alright, wish me luck. Hey, so I think I'm pretty much done with the inside of the router. Didn't do a very good job of managing the cables, I have to admit, but I think it's alright for a DIY project. So to give you a bit of a rundown, that's the two leads that will receive the 12 volt power, and that's the DC cable. When you supply 12 volt supply to these cables, what happens is it will go into this 12 to 48 volt converter, which then supply the DC volt to the 48 pins on this router, and also the same 12 volt will go into this circuit as well, which turns up the voltage to 15. Alright, and then that voltage is fed to this circuit, which then brings it down to 12.0. So theoretically I should be able to feed in anywhere from, I'd say, 9 volts to 15 volts, and I should still be okay because of this 12 volt setup. This one I've already tested with 11 volts, and it still outputs 48.5 volts, so I think I'm okay with this one. Yeah, so I still need to cover up this hole, otherwise I'm pretty sure some insects will find my router home. Yeah, I do need to cover this up. I don't know how I'm gonna do it just yet, but there are a few components that are sitting a bit prouder than the original setup date, so I can't use the original glass. Yeah, so still have to do something about it. Oh, also I've installed a fan underneath this BT. It's a small 30 by 30 mil fan, which is powered from this direct 12 volt supply. So I had a
yeah, so I don't think I did a very good job of this one, but it's the idea is not to rely on passive cooling anymore, because I've for once I've gotten rid of the original heatsink assembly. Now I've shown you earlier that I've installed some third-party heatsinks on the heat generating components of the Starlink circuitry. So even with that, I don't think I can rely solely on the passive cooling for this setup. Since I've got the 12-volt power already, I've installed a small fan underneath. So yeah, I'll give you a noise test as well when everything is done. Yeah, so the next update will be when I presumably have the front fascia installed, and hopefully I will have some sort of a connector. Yeah, we'll have to have some sort of a connector and plug this one up. So yeah, we'll see you in a bit. Right, a small update before I cover things up. That's how it's gonna look on the inside. If you can hear the fan, that's the noise is coming from the small 30mm fan on the inside. About the fan, in retrospect, I would have chosen to undervolt the fan to keep the RPM down. It doesn't have to be, this fast for this application, because I've got the heat sinks, third-party heat sinks installed on the heat generating components. It was originally passively cooled, so you don't have to have this much of a flow rate to keep it cool. If I do it though, I'd use a voltage regulator to, or even a resistor to keep the fan down. It's only 100 milliamps for the fan, so you could use a resistor to undervolt the fan. Yeah, and also I have measured the power draw. So at the moment the Starlink dish is actually sitting inside the garage, so it's hunting for signal. This is the highest power draw minus the heater in the dish. So if you have the dish heater turned off, which you should be doing anyway if you're doing this sort of a setup, yeah, this is the highest power consumption, is when you have the dish inside some sort of a shade. It's hunting for signal. So at the moment it's drawing about 6 amps from the DC circuitry, and everything looks to be alright, and nothing is melting down, no smokes, no smells. So yeah, it looks good, but I assume the 6 amps because I'm going through a double conversion here. If you do straight away plug into a regulated 12-volt supply for the 12-volt rail, at least I presume your amperage will be not much, I'd say about 30 to 40% lower from what I read on the internet. So I'm perfectly happy with this draw. Actually, this is the worst case scenario. So yeah, so the last step would be to cover this up. Let's see what I can come up with. Still hunting for ideas at the moment. Yeah, so that's it for now. So about the covering up, since the circuitry is sitting a bit proud from the original circuitry, I can't use the original glass in the original place. That's the original glass. I can't use the same original positioning because the circuitry is jutting out into the glass. So what I'm gonna do is I'm gonna put this rubber gasket in between the plastic housing and the glass. That way, this is a 6mm by 6mm rubber gasket. That way the glass will be sitting at least a 6mm higher than the original position. I think that's gonna be enough, but we'll see. Also, I'm gonna leave a little gap up there, or perhaps drill into the plastic surface so the fan can circulate the air, fresh air, from inside the outside. So you need an inlet and outlet. So fan is basically an outlet, which means I need an inlet to let the air in. Yeah, so that's the plan. Let's see how things go. Okay, so this is almost the finished product now. Still need to do a paint job, but for the time being, it's being held up okay. Yeah, as the silicon, it's not the best type of silicon for this application, but it did the job. And that's the fan inlet. No, this is the outlet for the fan, and that's the inlet. Yeah, sorry, not the best workmanship, but it did get the work. It did get the work done. Yeah, so for the all important speed test, that's my phone being connected to the Starlink, and let's do a speed test. Yeah, so it's okay. 58, 57, 70, okay, and that's the Starlink on top of the car. Yeah, 79 and 16.4 upload. Yeah, so yeah, I still need to finish this up. I do need to do a paint job and cover this up and maybe put a fuse in the line, and I'm gonna tuck this one inside the jack compartment, which is over there. So when the seats are in, you wouldn't be able to tell that this car has a router installed. So that's the idea. So yeah, that's pretty much it, guys. Thank you. So that's pretty much it, guys. Still had to do up the wire, but got a bit of a paint job. Yep, and the vents. Yep, that's how it looks. All running on DC power. Alright, cheers guys.